Hello and welcome back at the FinetLink channel. Now we are working with basic configuration at Cisco devices where the objective of this material is to implement initial settings including password, IP addressing, and default gateway parameters on a network, switch, and end devices. So far, we explained how to access a Cisco iOS device for configuration purpose. We explained how to navigate Cisco iOS to configure network devices. We even described the command structure of Cisco iOS software. And now we will configure a Cisco iOS device using a command line interface. We will use iOS commands to save the running configuration, and we even explain how devices communicate across network media. And lastly, we'll configure a host device with an IP address. So after we learn about the Cisco iOS, navigating the iOS and the command structure, now we are ready to configure devices. The first configuration command on any device should be to give it a unique device name or host name. By default, all devices are assigned a factory default name. For example, for switches, their name will be just switch. The problem is if all switches in a network were left with their default names, it would be difficult to identify a specific device. For instance, how would you know that you are connected to the right device when accessing it remotely using the security shell? The host name provides confirmation that you are connected to the correct device. The default name should be changed to something more descriptive. By choosing name wisely, it is easier to remember, document, and identify network devices. Here are some important naming guidelines for the host. You have to start with a letter, contain no spaces, and end with a letter or a digit. Use any letters, digits, and dashes, but be sure that it be less than 64 characters in length. An organization must choose a naming convention that make it easy and intuitive to identify a specific device. The host name used in the device iOS preserve capitalization and lowercase characters. Let's see this figure where there are shown three switches spanning three different floors are interconnected together in a network. The naming convention that was used incorporated the location and the purpose of each device. Network documentation should explain how these names were chosen so additional device can be named accordingly. And when the naming convention has been identified, the next step is to use the command line to apply the names to the device. The command that need to be entered is the hostname command, and it will be entered at the global configuration command, and it is shown here. So first of all, you have to go in the global configuration mode, which means that in this mode, in this level, you are able to configure anything about the devices. So after you will go in this level, use the command hostname followed by space and the name of the devices. And as soon as you click enter, you will see that now the prompt will change and you will see that there will be name of the devices. In this case is the name of the switch for floor 1. Always make sure the documentation is updated each time a device is added or modified. Identify devices in the documentation by their location, purpose, and addresses. And if you want to return the switches to the default prompt, you have to use the command no hostname. So in front of hostname, there will be a no space hostname, and then your device automatically will go in the default name, which will be switch. So let's go through the passwords. So remember that we use a weak or easily guessed password will continue to be the biggest security concern of organization. Network devices, including home wireless routers, should always have password configured to limit administrative access. Cisco IOS can be configured to use hierarchical mode password to allow different access privileges to a network device. All networking devices should limit administrative access by securing the privileged access mode, user access mode, and remote telnet access with password. In addition, all passwords should be encrypted and legal notification provided. When choosing password, you have to use strong passwords that are not easily guessed. There are some key points to consider when you choose the password. So, use the passwords that are more than 8 characters in length. Use a combination of upper and lower letters, numbers, special characters, and/or numeric sequences. You have to avoid using the same password for all devices, because if the password will be guessed, then all the devices will be hacked. Do not use common words because they are easily guessed. Use an internet search to find a password generator. Many will allow you to set the length, character set, and other parameters. So, when you initially connect to a device, you usually are in the user access mode. This mode is secured using the console. To secure user access mode access, you have to enter at the console line mode by using the line console 0 global configuration command. The 0 is used to represent the first, and in most of the cases, the only console interface. Next, you have to specify the user access mode password using the password command, and finally, you have to enable user access using the login command, as it is shown here. As you see, first you have to be in the global configuration mode, and then you have to go in the sub-configuration mode of the line console by using the line console 0 command, and after that you see that now you are in the line console by configuring that, which in this case we want to add a password. By using the password command, following with the password, in the materials that we are explaining, we are using the password Cisco and class. After that, you have to enable with the login command, and with the end, it means that now you have configured the line console. To have administrator access to all iOS commands, including configuring a device, you must gain privileged access mode. And it is the most important access method because it provides complete access to the device. So in this case, to secure the privileged access mode, you have to use the enable secret password in global configuration mode, as it is shown here in this example. So as you see, we are still configuring the switch at the floor 1, at the first floor. So again, go in the global configuration mode, and after you will be there, you have to secure your access with the command enable secret followed by the password that you will add for this level. You will configure the password for the access. And then by using the exit, you will go in the another level. So you will be out of the global configuration mode. And then the virtual terminal lines enable remote access using telnet or security shell to a device. Many Cisco switches support up to 16 virtual terminal lines that are numbered from 0 to 15. To secure the virtual terminal lines, you have to enter at the line VTY mode using the line VTY 015. From 0 to 15, you are saying that I am configuring the all 16 virtual terminals. And that you have to be in the global configuration command to use this command. Next, you have to specify the VTY password using, as in the line console, the password command followed with the password that you will add there. And lastly, same, you have to enable the VTY access using the login command. It is shown here. So first of all, you have to go in the global configuration mode, and by using the command line VTY from 0 to 15, you will be able to log in the virtual line, and you are configuring all of them. You will use the command password followed by the password that you will add. In this case, it's Cisco. Enable the VTY access with the logging, and with the end, you mean that you are done with the configuring with the VTY line, and then you will be in the access mode. But it is very important to encrypt the password. The startup configuration and the running configuration files display most password in the plain text. This is a security threat because anyone can discover the password if they have access to these files. So, enable to encrypt all plain text password, you have to use the service password encryption global configuration command as it is shown here in this example. So you have to be in the global configuration level, and by using the command service password encryption, you will be able to encrypt all plain text password. The command applies weak encryption to all encrypted password. This encryption applies only to password in the configuration file, not to password as they are sent over the network. The purpose of this, so it protects the device. The purpose of this command is to keep unauthorized individuals from viewing password in the configuration file. By using the command show running config, as this is shown here, you will be able that all the password that we configured in the previous slide for the line console, line VTY, and even for access mode, they all will be encrypted. But also requiring password is one way to keep unauthorized personnel out of the network. It is vital, to provide a method for declaring that only authorized personnel should attempt to access the device. And to do this, you have to add a banner to the device output. Banners can be an important part of the legal process in the event that someone is prosecuted from breaking into a device. Some legal systems do not allow prosecution or even the monitoring of users unless a notification is visible. To create a banner message of the day, it is called, on a network device, you have to use the banner message of the day, MOTD, followed with the hashtags in this example at the global configuration command. The hashtag in this case is the command syntax and it is called the delimiting character. It is entered before and after the message. The delimiting character can be any character as long as it does not occur in the message. For this reason, symbols such as hashtag are mostly used. After the command is executed, the banner will be displayed on all subsequent attempts to access the device until the banner is removed. You can see here that we are still configuring the switch at the first floor, and you have to be in the global configuration mode to configure the banner. And to configure that, you just enter the banner followed by MOTD, message of the day, space, and between the two hashtags, there will be the message of the day. And in this slide, there is a syntax checker where we will assign a device name, secure user access mode access, secure privilege access mode access, secure VTY access, and we will encrypt all plaintext passwords. As you see, you have to go in the global configuration mode. We will configure the hostname of the device. We are going to the line console to configure the access there. We even secure the privilege access mode with the enable secret command. And then we have to go even at the line terminal to configure them with a password. And then here we encrypt all the password, and we will even add the message banner where we will warn for only authorized access only. So now that we know some basic configuration on a switch, including even the password and the banner message, now we have to know how to save this configuration. First of all, we have to know that there are two system files that store the device configuration. We have the startup config, and this is saved configuration file that is stored in the NVRAM of your device. It contains all the commands that will be used by the device upon startup or reboot. Flash does not lose its context when the device is powered off. And to show the configuration that are stored in the NVRAM, you have to use the command show startup config. We have even the running configuration files that it is stored in the random access memory, and it reflects the current configuration. Modifying or running configuration affects the operation of a Cisco device immediately. RAM is volatile memory, which means that it loses all of its context when the device is powered off or restarted. And to show the configuration that are in running config files, we have to use the show running config command as it is shown here in this slide. And you can see that it is to view the running configuration mode, and the commands will list the complete configuration currently stored in the random access memory. And if the power to the device is lost, or if the device is restarted, all configuration changes will be lost unless they have been saved. So to save changes made to the running configuration mode, you have to save them to the startup configuration file. And to do that, you have to use the copy running config to the startup config privileged access mode command. But if changes to the running configuration mode do not have the desired effect and the running config has not yet been saved, you can restore the device to its previous configuration, remove the change commands individually, or reload the device using the reload command at the privileged access mode to restore the startup config. The downside to using the reload command to remove an unsafe running config is the brief amount of time that the device will be offline, causing network downtime. When a reload is initiated, the iOS will detect that the running config has changes that are not saved to the startup configuration. A prompt will appear to ask whether to save the changes. So in this case, you have to discard the changes and enter no, or just the letter N. Alternatively, if undesired changes were saved to the startup config, it may be necessary to clear all the configuration. This requires erasing the startup config and restarting the device. The startup config is removed using the erase startup config at the privileged access mode command. After the command is issued, the switch will prompt for your confirmation. And in this case, you have to press Enter to accept. After removing the startup config from NVRAM, you have to reload the device to remove the correct running config file from random access memory too. Unreload a switch will load the default startup configuration that originally shipped with the device. But after you configuring the files, you have to know that they also can be saved and archived to a text document. So here in this slide, we will use the steps that will ensure that a working copy of the configuration file is available for editing or reuse later. For example, let's assume that we have a switch that have been configured and the running config has been saved on the device. First, what you have to do, you have to open the terminal emulation software such as PuTTY or TerraTab that is already connected to the switch. And in this case, we are using the terminal emulation software PuTTY. And the step 2, you have to enable logging in the terminal software and assign a name and file location where you want to save the logs file. Here in this figure, it displays that all session output will be captured to the file specified as MySwitch logs, as it is shown here. And at the step 3, you have to execute the show running config or show startup config command at the privileged exec prompt, and the text will display in the terminal window, which will be placed in the chosen file. After that, the last step is to disable logging in the terminal software. Here in this figure, it is shown that how to disable logging by choosing the non-session login option. But remember that the text file created can be used as a record of how the device is currently implemented. The file could require editing before being used to restore a saved configuration to a device. To restore a configuration file to a device, you have to go through two steps. First of all, you have to enter global configuration mode on the device. And the second step will be to copy and paste the text file into the terminal window connected to the switch. The text in the file will be applied as commands in the command line and become the running configuration of the device. And this is a convenient method of manually configuring devices. So after we saw how to save even the configuration, now it is very important to know about the port and the addresses of the device. If you want that your end devices to communicate with each other, you must ensure that each of them has an appropriate IP address and is currently connected. You will learn about IP addresses, device port, and the media used to connect devices in this topic. So we'll learn about that in the previous videos. And we have video for each of those. The use of IP address is the primary means of enabling devices to locate one another and establish end-to-end communication on the internet. Each end device on a network must be configured with an IP address. And here are end devices that need the IP address. We have computers. They may be workstation, laptops, file server, or even web servers. Network printers need IP address. Voice over IP phones, security cameras, smartphones, and even mobile handheld devices such as wireless barcode scanner. The structure of an IP address, we know that is called dot decimal notation and is represented by 4 decimal numbers between 0 and 255. IPv4 addresses are assigned to individual devices connected to a network. With the IPv4 address, a subnet mask is also necessary. An IPv4 subnet mask, we know that is a 32-bit value that differentiates the network portion of the address from the host portion. Coupled with the IPv4 address, the subnet mask determines to which subnet the device is a member. And here it is an example that displays the IPv4 address of 192.168.1.10 with the subnet mask as 255.255.255.0 and the default gateway as 192.168.1.1. And these are assigned to a host. The default gateway address is the IP address of the router that the host will use to access remote networks, including even the network. And as for the IPv6 addresses, we know that there are 128 bits in length and written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. Groups of 4 hexadecimal digits are represented by a colon. IPv6 addresses are not case sensitive and can be written in either lower or upper cases. And here in the figure, it is shown how you can configure an IPv6 address, where you have to enter the IPv6 address, the subnet prefix length, and the default gateway, that they have the same function as the subnet mask and default gateway and IP address and the IPv4. Network communication depends on end user device interface, networking device interface, and the cables that connects them. Each physical interface has specifications or standards that define. A cable connection to the interface must be designed to match the physical standard of the interface. Type of network media included twisted pair copper cables, fiber optic cables, coaxial cables, or wireless are all shown here in this figure. Different types of network media have different features and benefits. Not all network media have the same characteristics, and we have learned about those characteristics. Not all media are appropriate for the same purpose. There are some of the difference between various types of media that includes the distance that the media can successfully carry a signal, environment in which the media is to be installed, amount of data and the speed at which it must be transmitted, and even the cost of the media and installation. Not only does each link on the internet require specific network media type, but each link also requires a particular network technology. For example, Ethernet is the most common local area network technology used today. Ethernet ports are found on end-user devices, switch devices, and other networking devices that can physically connect to the network using a cable. We have even the virtual interface that lets you remotely manage a switch over a network using IPv4 and IPv6 addresses. Each switch comes with one switch virtual interface called as SVI appearing in the default configuration out of the box. The default switch virtual interface is VLAN 1. So now let's go and configure some IP address. We have the manual IP address configuration for end devices. Much like you need your friend's phone number to text or call them, end devices in your network will need their IP address so they can communicate with other devices on the network. We will implement basic connectivity by configuring IP addressing on switches and computers. IPv4 address information can be entered into the device manually or automatically using the dynamic host configuration protocol. To configure that manually on a Windows host, you have to open Control Panel, Network Sharing Center, change adapter setting, and choose the adapter. Next, right-click on the and select Properties to display the local area connection as it is shown here in this figure. And then after you will be here, you have to highlight the Internet Protocol version 4 and click the Properties to open the Internet Protocol version 4 Properties windows, as it is shown here. And then here you can configure the IP address, the subnet mask, and even the default gateway. The IPv6 addressing and configuration options are similar, but after you open the adapter and the local area connection properties, you have to select the Internet Protocol version 6 properties, and at the window that will be entered, you have to enter the IP address, the prefix, and the default gateway. And as for the automatic IP address configuration on the end devices, you have to know that end devices typically default to using DHCP for automatic IPv4 address configuration. Dynamic Host Control Protocol, or DHCP, is a technology that is used in almost every network. The best way to understand why DHCP is so popular is by considering all the extra work that would have to take place without it. In a network, DHCP enables automatic IPv4 address configuration for every end devices that is DHCP enabled. What it means that DHCP enabled, that it's configured to obtain an IP address automatically. Imagine the amount of time it would take if every time you connect to the network, you had to manually enter the IPv4 address, the subnet mask, the default gateway, and even the DNS server. Multiply that by every user at every device in an organization, and you will see the problem. Manual configuration will also increase the chance of misconfiguration by duplicating another device IPv4 address. Here it is shown that you have to configure the DHCP on Windows PC. You only have to go, and after you open the local area connection properties, and after you select the Internet Protocol version 4 property, and at the window that it will be opened, in this case, instead of using the following IP address, so instead of configuring that manually, just click obtain an IP address automatically and obtain a DNS server address automatically. So that was about the end devices, but what will happen and how we have to configure an IP address to the switch virtual interface that was called SVI. To access the switch remotely, we need an IP address and a subnet mask that need to be configured on the switch virtual interface. To configure a switch virtual interface on a switch, you have to use the interface VLAN global configuration command. VLAN 1 is not an actual physical interface, but a virtual one. Next, you have to assign an IPv4 address using the IP address and the subnet mask interface configuration command. Finally, you have to enable the virtual interface using the not shutdown interface configuration command. After these commands are configured, the switch will have all the IPv4 elements ready for communication over the network. So, even for the switch, so if you want that the switch to be able to communicate with other devices, need to have a default gateway assigned. The IP address parameter should be IPv4 address of the local router on the network, and all the configuration on the switch virtual interface are shown in this slide. So you have to be in the global configuration mode, and you have to go to the virtual interface of the switch. So you have to, which is VLAN 1. So you have to log in at the interface VLAN 1, which means that now you are here, you are configuring the interface VLAN 1 of the switch by adding the IP address of the interface, and with the command not shutdown, you enable this interface. And remember that at the switch, we need also to configure the IP default gateway, and that can be done by just by entering IP default gateway at the global configuration command. And here in this slide, it is shown a syntax checker and how to configure a virtual interface of the switch, remembering that the VLAN 1 is a virtual interface for the switch, and by assigning IP address, you will be able to access the switch remotely when you need to configure or monitor the switch. And by using the command not shutdown, you will enable the switch interface. That was all about the second part of the basic configuration on Cisco devices. Thank you for being with us. See you to the next session. And if you like the video, please share this video with your friends. Do not forget to subscribe at this channel if you are new, and hit the notification button for the new videos that will be uploaded. See you soon.